you are watching the citrus varieties which are different in color, even in the shape also. These are the Japanese varieties, the star ruby which is red in color, and the other one is yellow in color and the red blackish color, and the other part, that is the barley varieties, which is showing differences in their inflorescence. So even you can watch these sort of the varieties in the nature. In the nature itself they are available, but they are in less frequency. So now coming to the mutation breeding, you all know that mutations are heritable changes in the phenotype of the organisms. Phenotype of the organism means they exhibit the morphological character changes. So when there is a change in the genes, then definitely there would be changes in the morphology of the organism. That's why these mutations are considered as a heritable changes in the phenotype of the organisms. So the term mutation was coined by Hugo de Vries in Enothena lamarckiana. So these changes are mainly due to the changes in the chemical changes at the gene level. These changes are capable of bringing about new and heritable character variations in crops. If these changes will be selected and used for the establishment of the crop, then it would become a good variety. So, but these mutations occur very low in nature. The frequency of the mutations in nature usually is very rare. That's why they are called as the spontaneous mutations. Actually, the term mutation breeding was coined by Prisleben and Lean, but the first time the report how these mutations would be exploited for the improvement of the crop was given by Muller and Stadler. So coming to the frequency of the mutations, if we want to increase with the help of the certain chemicals, we can able to increase the frequency of the mutations. So the rare frequency of the mutation can be increased by the application of the some physical and chemical agents which are called as the mutagens or mutagenic agents, and mutations induced in this way are called induced mutations. So these agents can be used to induce mutations in crop plants, and the desirable variations, whatever the farmer want or the customer want, they can be produced in this way. So the selection of the character is more important in any breeding protocol. So the approach of plant breeding, in which new variations of the crop or new varieties of the crops with desirable characters are developed with the help of the induced mutation, is called mutation breeding. So ultimately the final aim of the plant breeder is to release a new variety with the desirable characters. But here in this protocol the plant breeder is inducing mutations. Mutation, already we told that it is a heritable change. We are making some heritable changes by the induction, by changing the genetic material. That's why it is called as the mutation breeding. So and in the next slide you are going to know about the process of the mutagenesis and how the mutagens are helpful and their mode of action. So there are existing only two types of the mutagenic agents, that is physical and chemical mutagens. Coming to the physical mutagens, there are two types of the different types of the radiations available. So these radiations are classified into two classes, mainly based on their energy level. Energy levels are of two types, that is with low frequency and high frequency. So radiations with low frequency and radiations with high frequency can be employed as a physical mutagens. So first take the radiations with low energy level. These are capable of causing the excitation at the level of the nitrogen bases of the genetic material, and they are called as the non-ionizing radiation. Their function is only to excite the nitrogen bases, that is the excitation at the level of the nitrogen bases is doing by these radiations. UV light is the good example of the non-ionizing radiations. Then take the radiations with a high energy level. So when you observe the radiations with high energy level, they caused excitation at the levels of the nitrogen bases only. Their function is only excitation. But when you take the radiations with a high energy level, then they are capable of doing both functions, that is excitation and ionization at the level of the nitrogen bases. That's why they are called as the ionizing radiations. The best example are X-rays, gamma rays, alpha particle, beta particle, and are the good examples of the ionizing radiations. Coming to the chemical mutagens, the chemical mutagens are classified into 3 categories on the basis of their nature of the action, that is alkylating agents, base analogues, and acridine dyes. So all these 3 chemical agents perform their function in different ways. Let us watch how these chemical mutagens interact with the nitrogen bases and helps in the mutagenesis process. Coming to the alkylating agents, they induce the mutation by adding alkyl group to the nitrogen bases. The major alkylating agents are ethyl methane sulfonate, methyl methane sulfonate, ethyl imines. So they are shortly called as the EMS, MMS, and EI. So their role is just adding alkyl group to the nitrogen bases, causing the changes in the genetic material. So that's why they are called as the alkylating agent. They are also called as the radiomimetic chemicals. Why they are called as the radiomimetic chemicals means the mode of action of these alkylating agents resembles with the action of the physical agents. That's why they are called as the radiomimetic chemicals. So they are helpful in the AT-GC transition and GC-AT transitions. Next is base analogues, that is they are the chemicals which are analogous to the nitrogen bases. So they can get incorporated into the DNA at the time of the replication and are causing wrong